Yes, good morning, Senior 3. We have our Telegram lessons going on. I'm posting this video to explain some facts on electrolysis. Now, we define electrolysis and we're looking at the factors which determine the ions discharged at an electrode. And those factors were three. One is we're looking at the electrode. Series 2, nature of electrodes, and lastly was concentration. Now last time we were looking at electrochemical series and we said elements which are more reactive are discharged last. We said that looking at the metals we had potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, then mercury, silver, and lastly was gold. So these are the characteristics of metals. So when you put them the charges, they become charged ions. That's how they are. So these elements you see here, they are metals. So potassium is the most reactive, this is the least reactive. So if, for example, I have in a solution sodium, I have sodium ion and I have a hydrogen ion. We look at the two. Sodium is up, hydrogen is down. We discharge first hydrogen and leave sodium because sodium is more reactive. So it is higher in the reactive series but lower in the discharge or electrochemical series. So the less reactive metals are discharged first to leave in the most reactive metals. I gave you an example whereby if we have copper ions, if I have copper sulfate solution giving us copper ions plus sulfate ions. Then in that solution also this what there are water molecules in that solution. What is the weak electrolyte partially ionizes to give hydrogen ions and the hydroxide ions. Now we have copper and hydrogen. Come and look at carefully here. Copper and hydrogen. Copper is less reactive, hydrogen is more reactive. So we discharge copper and leave hydrogen. So you look at here at the anode reaction and then the cathode reaction. Anode reaction, so I take the anions. Cathode, we take cations. So here at the cathode, where we take cations, we take copper and leave hydrogen because hydrogen is more reactive. So we shall say copper ions in aqueous solution, they will gain electrons and electrodes forming copper solid. These are blue ions. This is a browny solid. So you know that here copper is browny and these copper ions are blue. So at the end of the process, the blue color fades. It becomes browny as a discharge. Whereas here we have the sulfate and the hydroxide. The hydroxide is less reactive compared to sulfate, so we discharge the hydroxide ion. So I'll take here hydroxide ion. At the anode, there is oxidation, we lose electrons, forming water plus oxygen gas. Balancing, we have here 3 oxygens, so I put here 2. Put the 4 charges, take off the 4 charges. Negative becomes positive, plus this 4 negative goes to 0, balanced charges. So here, this is oxidation. At the anode, it is oxidation because we are losing electrons. This is reduction because we are gaining electrons. So here we are looking at electrochemical series, and this condition only works for dilute solutions. Dilute solutions. Once they become conc, then we come to the next part of concentration. So, this is about our point about electrochemical cells. So here, take note, for the anions, sulfate is the most reactive, followed by nitrate, followed by chloride, bromide, iodide. Least is hydroxide ion. So the least reactive is the first to be discharged. The most reactive is last to be discharged. So let me ask you here, what is observed at the cathode? You will say that a brown solid deposit. At the anode, you will say bubbles of a colorless gas. So as this gas escapes, you will find that if this is your cell, where you have those solutions, this is your anodes, this is your cathode, this is where you have a dry cell, pushing electricity from, this is a dry cell, direct current, this is our anode, this is our cathode. And this is our anode. And this is our solution, that is copper 2 sulfate solution. Copper 2 sulfate solution. So what happened, I told you that at the end of the cathode you will see here a brown deposit. Brown solid. Then here you see bubbles. Here you see bubbles forming here. So you will see the bubbles of the colorless gas. So at the end of the process, this thing was blue in color, it will turn colorless. Why? You are removing the copper ions and hydroxide ions. So the blue color disappears or fades. Secondly, you will leave behind the hydrogen ions and sulfate ions, which means the solution time becomes acidic. If they ask you, if I put a blue litmus paper here, to turn from blue to red. Why? I'm leaving behind hydrogen ions and sulfate ions. The other thing I want to also give emphasis about is that why doesn't a solid compound conduct electricity? If I have magnesium sulfate solid and I have magnesium sulfate aqueous or molten, magnesium sulfate molten, this one can ionize, but this one cannot. No ionization. So you want to form ions here, that's why you will have no electric conductance. There will be no ions formed. But in this case here, you will form magnesium ions in aqueous state plus sulfate ions in aqueous state. Or here you have magnesium ions in molten state, liquid, plus sulfate ions in molten state. So they will ask you in your papers, explain why molten or aqueous solutions or total electricity of ionic compounds, they must be ionic compounds, not solids. Solids have compact ions which cannot move freely. That's why a battery worker, you go there to fill it with more water and acid. Why do you add their water? To make it aqueous, to make the ions mobile and free. Equally in liquid state, it also becomes molten and also becomes what? Free and can discharge electricity. Then, from the point number 2, nature of electrodes. When you put an electrode at the anode in its own solution, it will dissolve here. What do I mean here? For example, if I dip copper rod, a copper rod, I dip a copper rod in copper sulfate solution. This is copper, and this is copper 2 sulfate solution. So, and this is the positive, this is negative. This is positive, this is negative. So this is our cathode, This is our copper anode. Now, here what happens? Because I put copper in the copper 2 ions, this copper will dissolve in solution, going to the form free ions here. I repeat, the anode reaction. Anode reaction, you will have that the copper solid in that solution will ionize to give copper ions. So if they ask you a question, state what is observed at the cathode, you will say the copper rod dissolves to the solution. It forms a solution. Now, what is this coming from this side will come now here, form a deposit. A deposit. So this will be the copper solid deposit. What comes from this side goes down this side. So at the cathode, the ions which are coming here in solution from this side come here. So the ions in solution, recall that this one here we have here flow of electrons, here we have a flow of current I. So the coming electrons here come and find the copper ions inside here. They gain the electrons coming from this side and form back the copper solid. So if they ask you what's observed at the cathode, you will simply say at the cathode we have a brownie solid deposit. This chemistry is used in electroplating. Ewaka woli waliwe wuma, okay? Waliwe ejiko, those knives and forks, what we call cutlery. They have a silver coating. That silver coating came by this process. They put silver at the anode. They put the spoons, which is iron, on your cathode. Then the silver was put in silver-nitrate solution, whereby it could dissolve easily to form ions. The ions of silver came here to coat the spoon or the fork or the tray to a silver coating. And that's how we apply nature of electrodes. So online, shall have more questions and explanations, but for now, my point about that, the electrode put at the anode, if it's a metal, put it its own ions, it will dissolve. At the end, you will have nothing here. It will dissolve completely. At the end, you will have it disappearing completely. Why? The ions are living here, going into solution. And that's our today's lesson of Monday Senior 3. Those who are online, thank you so much. So I'll be posting these videos to keep you updated. Now, assignment says, state what's observed. Yes. Question. State what is observed when aluminum sulfate solution is electrolyzed using aluminum anode and iron cathode. That is our lesson. So I'm going to post this. You take the note, take the video, be pausing it as you copy some notes out from it. I will not give this week my notes typed. I'm giving you the video instead. Use it. So as a recap, a reminder, there are 3 factors determining the ions discharged at an electrode. Point number 1, I've told you, is the electrochemical series or reactivity series. If you forget it, this is the method. Kabaka never captured Masaka and Zaire. Florence should play hockey, cup, home and away. I repeat, Kabaka never captured Masaka and Zaire. Florence should play hockey, cup, home and away. That is the activity series of metals. Potassium most reactive, gold least reactive. For non-metals, you can say sulfate, nitrate, chloride, bromide, iodide, hydroxide. Sabani, new, clever, boys, isolated, heme. Sulfate, nitrate, chloride, bromide, iodide, hydroxide. So take this point very seriously. We shall apply this thing in our day-to-day life. For example, the ions discharged during the bulb, the dry cells being used, the accumulators, these solar batteries, we apply the science of electrolysis. I told you here, natural electrodes, even if I dip a metal, but you take note here, come back this side. Here I've dipped copper in copper ions. But equally, if I dip, for example, zinc in hydrogen ions, because zinc is above hydrogen ions, equally zinc will dissolve that hydrogen ions. I repeat, if this was zinc and these are hydrogen ions instead, equally zinc will dissolve. As long as what is here and here the same, it will dissolve. Or if the metal here at the anode is above the ions here in the series of the activity, it will also dissolve. And that's how the electrolysis will take place in this case. What I told you that ions won't be